We're going to hear from Jeff Woodward on soil health practices and NRCS technical and financial assistance programs. Jeff, we're so happy to have you with us here today. Thank you so much for joining us, and I am looking forward to learning from your presentation. So if you'd like to take it away, I'll hand it over to you.
Hello, my name is Jeff Woodward. I'm the area resource soil scientist in West Tennessee. I cover all of Area 1 from basically from Kentucky state line down to the Mississippi state line and from the Mississippi River to the Tennessee River. I provide support for all the field offices here in West Tennessee and do a lot of wetland determinations and also try to get the soil health information out to the public and to help out any way I can to increase soil health use here in West Tennessee, may it be large farming practices or small urban gardens. If we can get that soil health on the ground, all the better. Why are these invertebrates mattering so much? She talked about quite a few different little critters that live in the ground and everything. What kind of functions do they provide to the soil? What do they help with? And that's what we're kind of wanting to do with soil health. We are trying to increase these invertebrates and bring our soil back to life, and they create a symbiotic relationship with the soil. So if we can create the situation for those invertebrates to thrive and do well, then they're going to really bring that soil health back. Some of the things that we do to destroy our soil viability and the health of our soil is excessive tillage and disturbances. When we plow the ground, even till it up with a rototiller, that is really disturbing that habitat that those microorganisms and other invertebrates need in order to live. And also, another thing that we do a lot of times, besides just tilling the ground, is we use monocultures. Even in gardens, we always plant the same thing down the same rows every year because that's the way Grandpa did it. I know I always remembered my grandpa always had the tomatoes down the same row, always had the green beans down the same row for years and years and years as I was growing up. And by doing this, that is not creating a very good life cycle in the soil. It's definitely increasing the chances of causing problems with disease and also just not creating a good environment for all those invertebrates to live in. And so if we can bring that soil health up back together using these core soil health principles that we have here, minimizing soil disturbance, maximizing the soil cover, integrating livestock whenever we can, and even on a small setting, livestock can be integrated in, and we'll look at that. Keeping that continual living root in the soil year-round and increase the biodiversity of the soil or the vegetation that we use in that soil. And one way that we've done minimizing soil disturbance, especially here in West Tennessee, is by no-till farming. We have a lot of erosion problem, so it was just a smart thing to do by adopting no-till farming, and that helps minimize the disturbance. And most of the farmers here do no-till or very minimal tillage, which is a good accomplishment. That was one thing that's really improved our erosion situation here in West Tennessee. I can still go out and into the field and find old gully scars where even on my property, I bought 50 acres and probably half of it was farmed at one time, but even as far back as the 1960s, it had gullied out so bad that they had to stop farming a majority of that property. And it was just basically a giant scar where the soil used to be, and it's recovered into woods, but it's still, when you go out there, you see those scars, you see that abrupt gully erosion, whereas if you go into the place that was never farmed, it has a nice gentle rolling landscape, the way that nature intended. And by reducing that tillage, it's going to do a lot of benefits. It's going to help preserve that structure that's in the soil. By tilling up that soil, you are really breaking down that structure, and you are also decomposing the organic matter at a higher, quicker rate in that upper surface. So if we can reduce those tillage practices, it's going to help protect that life zone for those invertebrates. It's going to help increase infiltration. It's going to help maintain the organic matter in the soil, and it will help the soils function better. It's going to be less wet shortly after a rain because it's able to infiltrate in quicker. In this little picture here, you can see kind of how that life ceases as the more conventional tillage you do, the worse the structure becomes, and you just do not have the habitat for all those little critters to live in. And here's a picture of that undisturbed soil on the left compared to a highly tilled soil. And I can find that, go out to the field and look for a place that had a long history of tillage, especially in the river bottoms where they still till it because it's flat. And recreational tillage is just so much fun. So you can go out there and you can find like what he's holding in his left hand there, where there's just no organic matter left. The structure is completely broke down. Most of the time when you look at it, it looks like a lot of plates sitting on top of each other, compared to the one that is a nice, healthy, robust soil with good structure, lots of pore space, a lot of room for movement of those invertebrates in the soil. And one of those tests that we can check to look at the importance of that soil structure is a slake test. And I've got a little video here. With the that soil stability test there, that slake test, that's a great way of seeing how that tillage has just absolutely destroyed the life in the soil, and it just does not have that pore space anymore for all those little critters to live in, and it just has, the organic matter has been decayed, everything is falling apart, and there's that glue of life that he talks about has just completely vanished from that tilled soil. So this is a great thing that we use to try to express the importance of adopting the soil health throughout NRCS. This is something that we always try to show the farmers of why they should adopt healthy soil practices. And another thing is maintaining that continuous living cover. If we have something living year-round in that soil, it's going to really help rebuild and regenerate the soil that we have. And that, by doing that, using cover crops, that is the great way for us to accomplish this. And the cover crops can be many different things. And the larger variety, to get away from those monocultures, the more different cover crops that we choose, the more benefit that we're going to get from it. And this is going to really help increase that soil moisture moderation. It's not going to be super wet in the wet times after a heavy rain. It's going to dry out faster because of the infiltration is going to increase. You're going to have a lot more life in the soil. And also you're going to start getting that fungal growth in the soil that's going to help benefit your plants that you're raising to hopefully make a profit on your land. And all, like here, it's listing vetch, cereal rye, clover, and daikon radishes. And here's an example of how these roots of these different plants go into the soil. This ryegrass and cereal rye and annual rye and winter wheat are very common cover crops. And a lot of times, if you're just beginning farmer that's just now starting to get into doing soil health practices and they want to just do it themselves, that cereal rye or annual rye is a very common beginning cover crop. And as you can see, it sends roots deep down into the soil, which really helps scavenge the nutrients that are deep in the soil that have washed and eroded down into the soil. But also, if you notice over to the right, there's a radish there. And that tuber is also going to help break up that platy structure in that upper surface where that organic matter and tillage has really just sealed off that surface of the soil. And we got some other here. And it can be something that grows in the fall, throughout the winter. Right now, we had a really dry fall, and so a lot of the cover crops didn't get that initial takeoff like we would hope. But I have seen a lot of radishes and turnips out in the fields, but they did get frozen during that really rough winter spell that we had here a couple weeks ago. The daikon radish is a very common addition to this cover crops, and those big roots, those big tuberous roots, really help open up the soil, break it open to allow for that water infiltration, and it starts regenerating those pore spaces for all those invertebrates to live in. But it's something that can also be done during the summer. If you have a field that's idle, but you would really still like to have something growing out there and creating that cover and those living roots, things like sunflower, buckwheat, and different legumes you can add to there that grow during the warm season. And there are summer cover crops that NRCS can develop a schedule of summer cover crops if you would like to get some on the ground. If you have a part of your garden where you harvested it early and it's just vacant right now, hey, we can add those summer covers to it. And you can also have the enjoyment of flowers like sunflower, and you can even harvest those sunflowers later on in the year. And here's another example of a few more. Winter pea. The great thing about those legumes is you start having nitrogen fixing bacteria on those roots, which are going to really help feed those the next round of vegetation that you plant in there, especially if you're growing corn. It's going to help save some nitrogen in the soil for those corn plants to grow. And if we can really maximize the biodiversity of of the things that we grow, whether it be in a large agricultural operation or in a small garden setting, it's really going to help improve our soil functioning and bring that life back to the soil. If we can plant native species, all the better. And this can be done even in a garden setting, say with these raised beds here. If you rotate these, instead of just planting the same thing every year, maybe we'll do a root and bulb in one bed this year, and then switch to a fruit and seed the next year, and then switch to a leaf and stem the next year, and then maybe have it fallow for a year with cover crops. and it's going to help bring that biodiversity back to your soil, even on these small settings like in a garden or an urban setting. And also, if we can do some continuous carbon inputs to the soil through the use of composting and adding that organic matter, it's going to give food to all those invertebrates to help really build that soil back up, and it jumpstarts that nutrient cycle and brings that soil back to life. Um, if you add manure, compost, if you retain that residue, a lot of the farmers will turbo till the residue, which is kind of defeating the purpose of having the cover crops because it is breaking that residue down faster than what it should. And it is also kind of inhibiting that life cycle in the soil. If you have good life cycle, that residue should start decaying at a fairly rapid rate. If you're seeing, if especially like on farming situation, if you're seeing uh, corn and bean rotation, and you see 2 or 3 years of stubble leftovers, so if you grew corn last year and you grew soybeans the year before that, and you're still seeing those soybeans from the year before that, then there's something that's not functioning well in your soil. You don't have that life cycle in there that's really helping break down those residues. And so if we can bring that back up, keep that residue growing, create that habitat for all that life, adding manure and compost to the soil, then hopefully that residue will start breaking down at a rapid pace and really start feeding those life cycles in the soil. Now I have another video here. I will try not to kill myself on the presentation. So that really helped describe that nitrogen cycle and how important it is to help to have that life cycle through proper soil health processes to really build that life back up into the soil and get that nitrogen cycle back to a natural state. Um, and so hopefully our end goal is to reduce the reliance on those chemical fertilizers, which, as you can see there, actually increase the problems that we're facing by killing off or driving away those that life that's in the soil or should be in the soil from doing its normal chain life cycle and providing that nitrogen to those plants through a symbiotic relationship. And the next step is adding livestock wherever appropriate. And that livestock is really going to help add organic matter to the soil through their droppings. And even in a urban setting, this can can take place through the use of poultry and small ruminants in your cycle through your garden. If you have a small area that you are wanting to plant a certain type of crop for your more of an urban setting, if you can add a few animals to there by them um, doing the business that they do, then it's going to help add that organic matter back to the soil. It's great using uh, intensive grazing in a cover crop. It really helps rebuild that life back into the soil through their organic matter and breaking down of that vegetation to something that's really uh, a great food for the bacteria in the soil to consume. Another thing that we can do to really help the natural ecosystem is creating buffer strips and a zone along the edges, riparian buffers. We try to do this in large agricultural settings through these buffer strips along channels and it provides habitat for a lot of these invertebrates like the bees to live in, some of these ground dwelling insects that they can live in these buffers and then proceed out into the cropland as they need. But you can also do that in a smaller setting. You can create a little pond here, as you see in this picture here, that has a really diverse amount of life around it, vegetation wise, and this is going to create a good habitat and a lot of resources for the other little critters that live in the soil. You can do a pollinator habitat, which is really going to help bring back the things that's going to benefit not just your flowers or the little insects, but it's also going to benefit the things that you grow in your garden. And how can NRCS help any of our customers with these processes? One of the best things that I can do as a soil scientist is doing a soil health assessment. And any of the field offices throughout West Tennessee can provide this service, or anywhere across the country, you should be able to get this service done through your local NRCS field offices or your area resource soil scientist. And an on-site soil health assessment is going to really help you to figure out what do you need to do to really improve your soil health. One of the first things that we can do to really check it out is doing an infiltration test. If we have a baseline assessment, it's like, hey, we're not getting any of this rainwater that you're really wanting to get. You tilled up this yard or this garden, you plowed these fields in order for the rain to soak in. Well, is that really happening? And that is something that we can see here. So if we use these little practices to help show them these baseline soil health that they have in their soil, they can learn what do they need to do in order to improve those things. Soil organic matter testing. It's something that can be done through a physical look at the soil. Is your soil nice and dark and deep and lush like this over here on the right? or is it very light colored? A lot of the soils in West Tennessee, unfortunately, have very minimal amount of organic matter in that topsoil, and so they are looking a lot more like the soils on the left that are very light. There's no more organic matter left in those soils. So that's a really good indicator on what kind of conditions that you might have in your garden or in your crop fields. And by using that aggregate stability test through a slake test, that right there, it was a great first example of, hey, how healthy is the structure in my soil? Is there that glue of life in that soil to help hold the soil in place and help provide habitat for all these invertebrates? Another thing that we can use to assess the healthiness of your soil is doing an earthworm count. She showed the many different kinds of earthworms there were, and I like to dig up a cubic yard of soil or cubic foot of soil and go through that entire cubic foot and count how many earthworms do we have and what kind of earthworms do we have. You can also use that by the midden counts on the surface. Are you seeing a lot of the vegetation being pulled down into those earthworm burrows, or is it pretty well just nice and barren of any earthworm activity? If we can see that we're a lot of earthworms, that's showing that our life cycle is doing pretty well in the soil compared to the sample on the left where there's just no real good habitat and it's void of any earthworms. I have done this test in an area where it had a very biodiverse cover crop. It had like a 7-way species mix. Went out there in May, and it was a very hot May. We had already had temperatures pushing 100 degrees. And I went out into that and I went through a cubic foot of soil there, and I counted like 200 earthworms in 1 cubic foot of soil. Where I went to another field that had cover crops, but it was just a single cereal rye, non-diverse cover crop. And I dug up the soil had pretty decent structure from being in cover crops for 40 years or 35 years, but that particular vegetation didn't really create the habitat that those earthworms wanted. Since it was getting hot and dry, they were going either deeper or off to the edges of the fields where they could find a life or an area where they could live a lot more comfortably. And I only counted like 6 earthworms in that cubic foot of soil, even under a cover crop. But by having a really diverse cover crop, multi-species, then I saw a definite difference in those earthworm counts. Your infiltration test, like I was saying, that's a great way to see how well the water and nutrients can get into the soil. You can buy a kit like this, or you can create one with a coffee can and some saran wrap and a bucket of water. And basically you're wanting to drive those rings about 3 inches into that surface of the soil, and then get you a standard water bottle. It's like 500 or 444 milliliters is what the scientific amount is, but most of those water bottles have 500 milliliters in them. And so that is pretty well a good idea of how fast that infiltration is. And then you can time how fast that water soaks into the soil, and that shows you how many inches per hour or how many inches per hour that soil can take in. If I've gone into some fields that have not had a very healthy soil health characteristics, and 30 minutes and that inch of rain has not soaked into that soil. But we did some in an area where you had cover crops that had been there for 25 years, and it had a very good structure rebuilt. The platiness of the structure from it being tilled was pretty well broken up, and we were getting 7 inches per hour of infiltration in that study that we did. So it really makes a big difference and really is a good example of how healthy your soil is through those infiltration tests. And so by doing these assessments, looking at these basic things, it's going to help create a baseline of where is your soil on your site, whether it be a small garden in an urban setting or if it's a large farm field. We can use this as a baseline and then check it periodically to see how these soil health practices have brought that soil back to life. But, a lot of times the things that are stopping us from doing these practices is financial. The money isn't there. Why I can't afford to buy these cover crop seeds. I can't afford to do these practices because I'm just barely breaking even just growing a crop as it is. And so the NRCS has some great funding options to really help fund these soil health practices. And the EQIP is a great way of fixing these problems. The EQIP, the Environmental Quality Incentive Program, is going to give you financial assistance to implement these practices. It's going to help reduce that tillage, add cover crops, pay for the cover crop seeds, do nutrient and pest management planning, organic assistance, buffer strips, intensive grazing, things like that. And so if we can apply for these EQIPs application to address those resource concerns, then it's really going to help benefit you financially and encourage these farmers to adopt these healthy soil practices. Another option that we have is the Conservation Stewardship Program. And it's more of we're going to reward you for doing a good job and continue adding more of that conservation to the land. And a lot of the farmers, after they've gone through their EQIP practices and have set up a good habitat and have done a lot of conservation work, then the CSP is going to help provide some extra financial assistance to reward their good behavior on these sites. What are the practices that you can apply for or ask for? As a typical government agency, we use a lot of numbers and acronyms, and sometimes they're hard to remember, but I'm going to give you a few examples here of the practices that are available to help really bring that soil health back to your soil. One of them that is minimizing that disturbance. So we have these practices here, like residue and tillage management, 329 and 345, conservation cover, 327, nutrient management, 590, integrated pest management, 595, and prescribed grazing, 528. These core practices are going to help minimize that disturbance to your property, which was one of those 5 building blocks to soil health. Another one is that cover crop. Cover crops is 340. We do a lot of that, and it's been paying pretty good. You can either maybe make a little money or break even on adding those cover crops to your practices, and that's really going to help get that life cycle rebuilt and regenerate the soil. You have residue and tillage management, 329, 345, conservation cover again. You can add mulching. If you have an area that is just constantly bare, you can use a mulching practice in order to help bring some cover to that site to really try to help control those problems. You've got controlled traffic, 334, pasture hayland planning. So instead of trying to grow a crop out there, you've got an area that's really, it needs to have some rest and rebuild through grass pasture and bring that life back through that way. And then the prescribed grazing, it's amazing how much life doing a very well maintained grazing practice, even through flash grazing, mob grazing, it's really bringing the life back to the soil by adding that livestock back to it. And so if we can give an incentive in order for these farmers to do prescribed grazing through our EQIP, then that's a great step forward. How do we maximize the living roots? Conservation cover crop rotation. Try to make sure that they got a really good crop rotation going. The conservation cover once again, the cover crops once again, pasture hayland planting, prescribed grazing. These are going to help maximize that living root and also maintain a more biodiverse setting on your farm. And another way to maximize biodiversity, it's once again, we've got a lot of these same practices that are checking the bill, market, they're a check mark to really help bring that soil health back to your place, using livestock as an additional thing to your biodiversity. Also, it's going to really help rebuild that soil. And so some of these core practices, you can see that how they check off those different boxes. Conservation cover, look, it's doing disturbance, it's doing cover, it's doing diversity, and it's keeping living roots. Some of them might only check one box, like nutrient management. It's really just to stop that disturbance. But you can have that and multiple amounts of these different practices in your EQIP application, and it's going to all check off these boxes, and your goal is to try to get all of them checked off and to benefit and add extra benefit through these different program offerings. Here's some more. Prescribed grazing is checking them all off, where integrated pest management is maybe only checking off your diversity and disturbance. So you can see how these different practices help mark off different things. And, NRCS can help clients participate. If you go to your local field office, whether it's in an urban setting, it doesn't matter if you have just a small 1 acre tract or if you have 10,000 acres. Our job is to serve our customers. And NRCS provides this by giving field visits, consulting with you, doing a soil health assessment, do some conservation planning, and helping you to apply for the EQIP or CSP. And then they're going to help you design, install, and monitor the processes and help that payment make sure it gets to you, especially if you're a beginning farmer or an underserved farmer. Then it's going to really adds a lot of benefit to you, and all you have to do is go to your local field office and ask for that help. And that's what we're there, is to serve our customers. And if we can get our conservation on the ground by serving our customers, that's our goal. So, if we can go out there and we see those soil health indicators, we can see an improvement in our organic matter, an increased infiltration rate, our bulk density is improving, your aggregates are not slaking away. We're seeing all those little critters coming back to the soil, and we're reducing the erosion, and hopefully you're increasing your yields, whether it be in a garden or in large agricultural operations. If you can increase your yields and decrease your inputs, that's going to make you more profitable and lower your bottom line and really help you in the long run. And that's our goal with NRCS, is to try to be able to provide that for the customers. And those soil invertebrates are very critical to the functioning of our soil. If we don't have those, then we're not going to be able to grow things without spending massive amounts of money on fertilizers and pesticides and nutrient or in mineral additions and things like that. But if we can do it in a natural way and reduce the amount of chemicals that we're starting to see, glyphosate is causing problems, paraquat is a lot of problems. There's a lot of different chemicals we're adding to the soil that is affecting our water quality, is affecting our way of life. So if we can help reduce those through proper conservation practices, whether it be in a small farm or a garden, or whether it be in a 10,000 acre farm, if we can help reduce that and reduce those problems that are being caused to our environment, that's our real large picture goal. And through EQIP and CSP, where you can help these farmers and our customers to implement and sustain these practices. So thanks for being here on this, and hopefully you've learned something about how NRCS can help and the importance of cover crops and soil health, and to really bring back all these little critters to our soil, which are very important to the overall life cycle in our environment. Any questions?
Thanks so much, Jeff. That was great. It's good to see the science and then the practical application of this, and how it looks in the field. So I appreciate that perspective very much.